Lesson 19, polygons. So a polygon is a closed figure. It's 2 dimensions and all the lines are straight. So the definition we're going to write is closed 2-dimensional figure with straight sides. So I'm going to show you some polygons and some non-polygons, so you can see examples of both. So we're just going to title, this group that I draw here will be polygons, and this group over here will be not polygons. So here is a polygon, a triangle. It has all straight sides, it's closed, it's 2-dimension. This is a polygon, looks like a Christmas tree, but it has all straight sides and it's closed, 2 dimensions. Here's another one. There we go. These ones over here are going to be not polygons. So the letter D has a curvy side that is not a polygon. Here's a figure that kind of looks like it's going to be a triangle, but then we don't finish, so that's not a polygon. A circle's definitely not a polygon because it has curvy side, doesn't have straight sides. And if you overlap sides, that's not a polygon. So like a bow tie would not be a polygon. Now a regular polygon, we call them regular if all the sides have the same length and all the angles have the same measure. So we're going to write equal sides and angles. Equal sides and angles. So that's called regular. If you have a polygon that's not regular, we call that irregular. So you'll have lots of questions that say, is this polygon regular or irregular? A vertex is on a polygon, and it is the point where 2 sides of the polygon meet. So if you look at our group of polygons, any 2 sides meet at this point. That's called a vertex. So every point like these are called vertices or vertex. Congruent, when you see the word congruent, it just means same shape and size. And the congruent symbol is an equal sign with a little similar symbol right above it. That means congruent. Same shape, same size. Similar means the same shape and not necessarily the same size. And that just is a similar symbol. It's just a little tilde. A dilation, one type is called an enlargement. Another type is called a reduction. So if it gets smaller, it's a reduction. If it gets bigger, it's an enlargement. So the enlargement, we're going to draw like a little one, a little triangle, and then a bigger triangle. And they're supposed to be exactly the same, or the sides are in proportion to each other. They're just one's bigger than the other. If we want to name a polygon, we pick a letter and we name all the letters around the figure in order, clockwise or counterclockwise. It doesn't matter which way you go around it, as long as you're naming each letter all the way around the polygon. So we name each vertex in order, clockwise or counterclockwise. And it doesn't even matter which one you start with, as long as you don't miss any of them and go all the way around. So we're going to draw a figure ABCD that is a polygon. There's so many ways that you can name this. We can name it ABCD. We can name it ADCB, BCDA, BADC, etc. So the first one we just started with A and we named it around clockwise, and then we went counterclockwise. The second group I started with B and went clockwise, and then I named it counterclockwise. So you could do 4 more. You can start with C, go both ways, and D, go both ways. That's lots of different ways you could name it. So here's an example. We have a multiple choice, or I'm just gonna, I don't even know what I'm doing here. We got an A. This looks like a multiple choice question. I'm not sure. We're gonna make it a right triangle. B, we're gonna try to draw the same triangle, only a little baby one. C, we're going to draw the same triangle as A, but only put it backwards. So try to make it about the same side lengths as A. And then D, we're just going to draw a random triangle that's acute. All the angles are acute. So we can look at these and talk about them a little bit. We could say triangle A, so we can put the little symbol triangle and call it A, is congruent to triangle C. And that's because they're the same size, same shape. Mine doesn't look very good, but let's pretend they are the same size, same shape. Triangle A is similar to triangle B and also similar to triangle C. So if you write it this way, all 3 of them are similar to each other. And we could say triangle A is a dilation of triangle B. And that's the end of the lesson.